What is quantum mechanics? You know how Minecraft has its own logic, blocks float, redstone powers machines, and mobs behave predictably? Now imagine if some of that predictability disappeared. You are left with quantum mechanics. Basically physics on a microscopically smaller scale. In quantum mechanics, we learn about particles. Now, what are particles? Think of it like a Minecraft pixel, so small that it's the foundation for everything else. But unlike a pixel, particles are alive in a way. They're constantly moving, changing, and interacting with their surroundings. These particles have 6 primary properties. Now, spin does not mean that a particle is physically spinning or moving. It's more like a built-in direction the particle prefers. Spin is an intrinsic property of a particle that helps us see how the particle would react if it's exposed to a magnetic field. Also, the spin can be either up or down. So if the particle is a mob, the mob can look only forward or backward. And let's say that a beacon is the magnetic field. If the mob looks at the beacon, its spin is up. If it looks in the other direction, its spin is down. Basically, like the hunger bar in Minecraft. If you have a full bar, you can sprint and move faster. If it's low, well, you can't sprint and you move slower. This is self-explanatory, the coordinates of a specific block in Minecraft. This is like the enchanted books. You can have a positive effect, a negative effect, or the book can just be a book, neutral. Basically the difference between a dirt block and a gold block. While some particles can be light like a dirt block, others can be heavier like a gold block. Basically, how a particle would react if we put it in a magnetic field. So for example, the compass in Minecraft always points north in the world of Minecraft. So if the compass was a particle, we can say that its magnetic moment always points north in the magnetic field of the world of Minecraft. These are the 6 main properties of a particle. Now that we know all of that, we will see some basic concepts of quantum mechanics. Superposition is when a particle can exist in multiple states at once. Dig a hole in Minecraft, put a zombie there and seal it. Now, if you walk away, superposition dictates that the zombie is both in the hole and it's despawned at the same time. And you can't know until you look in the hole. So, the zombie is both in the hole and not in the hole at the same time until you look. When you look, it decides if it is in the hole or not. This is the idea that you can't know a particle's exact position and speed at the same time. The more you know about one, the less you know about the other. Think of an Enderman. If you're trying to track where it's teleporting, you can't know both its exact location and how fast it's moving. If you focus on its location, it teleports unpredictably. If you watch its speed, you lose track of where it's going. Particles can act like waves or solid objects depending on how you observe them. In Minecraft, imagine a zombie that's both a mob and a flowing water block. If you're looking at it, it behaves like a solid mob. But if you stop looking, it acts like water, spreading out and flowing. This happens when a particle goes through a barrier it shouldn't be able to pass. It's like you glitching through the nether roof that is made of bedrock. You are not supposed to be able to pass through bedrock, but you somehow glitch through it for some reason. When 2 waves meet, they combine to form a new wave pattern. Picture 2 water flows meeting. Where they overlap, the waves get bigger or cancel out. In quantum mechanics, particles do this too. When two particles are entangled, they're connected no matter how far apart they are. Changing one instantly changes the other. When you have two ender chests, let's imagine that an emerald is a particle. If you put the emerald in one of the chests, it will always appear in the other ender chest no matter how far apart they are. This happens in real life. Two particles can be on the two sides of the universe. And if you do something to one particle, it instantly happens to the other. This is when simply observing a particle changes its behavior. Imagine a mob that freezes the moment you look at it. Its behavior depends entirely on whether it knows you're watching. Quantum decoherence is the process by which a particle chooses a state when it interacts with its environment. Before this happens, the particle exists in a superposition of states, but decoherence forces it to settle into one. It's like the particle is being observed by its surroundings, which locks it into a specific state. Imagine you're building a redstone contraption, and you place a block of redstone dust. While it's in your inventory, it could potentially be used as part of any mechanism, doors, traps, or lights. But once you place it in the world and connect it to something, its role is decided. Decoherence is like committing that redstone dust to a specific purpose. Before you placed it, it had infinite possibilities. Now it's just a power source for your door. The quantum Zeno effect says that if you keep observing a particle continuously, you can stop it from changing its state. It's like watching something so closely that it freezes in time. Imagine a sheep in Minecraft that's about to eat grass and regain its wool. If you keep staring at it, it never eats. The moment you turn away, it munches on the grass and regrows its wool. The quantum Zeno effect is like this. Observation prevents the system from progressing naturally. Entropy in quantum mechanics is a measure of disorder or randomness in a system. It's about how much information we don't know about the 6 properties of a particle we saw at the start of the video. Think of a double chest filled with random items, diamonds, dirt blocks, and seeds, all mixed together. The more random the arrangement, the higher the entropy. If the chest is neatly organized, all diamonds in one row, all dirt blocks in another, the entropy is low, because it's easy to predict what's where. A high entropy quantum system is like that chaotic chest. You don't have enough information to know its exact arrangement. And now, if you understood everything in the video, you know about 20% of quantum mechanics. This is obviously not all of quantum mechanics, but otherwise this video would be over 10 hours. But still, this is a good foundation. And this would be everything you want to know about quantum mechanics. Believe me. If you like this type of content and want more, please consider subscribing. Thanks.